Hi, good evening. My name is Emilio Trasviña, and today I'm going to present you my Integrative project, which is a reactor automation for chemical products. And well, here's a little index about what are we going to see in this presentation. But let's start from the beginning. Well, this is the name of the project, which is Satori's 5555. And you might be wondering why that name and why such a long number. Well, the Satoris come from in honor to my dog, Satori Storby. The Satoris is a kind of German Shepherd dog breed, which is another line from the dog we everyone know. Uh, this specific type of dog is a work dog. It's not a pet. Well, you can domesticate it, but it's not that simple because they are super hard to train. They have a pure genetic, which is more compared to a wolf, and is high valued because some of the lineage in this line are IPO World Championship. They come without diseases, and what I want to represent in my project is the pureness and the quality we want to achieve and actually success in the middle of this project. So that's the name Satoris. That's why it's the name Satoris. And the big number is just because I like a movie of Daft Punk, which name is Interstellar 5555. So with that clear in mind, the aim of the project is only to automate a process tank focused on the manufacture of chemical cleaning products to improve the efficiency of the companies that use these types of reactor, because you might use it, but the process, not all the process all the same despite you use the same types of reactor. So what we want to use, it depend on the type of process you're doing. We can automate this process and make it faster, easier, and reduce the cost that will generate to enterprises by paying another guy that, well, paying Manx is also very expensive. So, well, the main idea, the problematic search in my job, I work in Macroclean Química, Durango, which is an enterprise that is dedicated to the fabrication, distribution, and production of chemical cleaning products. So while I was working there, we use reactors to produce all chemical products, but the process is kind of slow. It's kind of hard because you have to carry on all these bottles. The containers are super heavy, and sometimes it's dangerous even for the people who work there to being exposed to all these chemicals. And despite we have the right protection, there's always a risk. So we want to try to reduce that limit by automating the raw material that is come from containers, just directly pouring them into the reactor, and that reactor is going to have a motor which it's going to help to make a homogeneous product without any contamination. So we are only focusing on the cleaning area products, because you might say, well, you can use it for producing, for example, drinks. And yes, technically you can do it, but in my case, I don't want to deal with any of the rules because they're super strict. If you're going to produce food, you have to be super clean, you have super high quality standards, and I just don't want to deal with that. On the other side, well, a quick description of the project is that, okay, you have the reactor, and that reactor will contain the final product and is going to mix all the raw material. But that material is going to be dosed by containers connected to electrobulbs. In your, with a matricial keyboard, you're going to press it and you're going to select how many kilos you want of each container. For example, imagine you have 3 containers, A, B, and C. If I press on the keyboard 3 kilos of letter A, 5 kilos of letter B, and 7 kilos, for example, of letter C, it's going to be dispensed for electrobulbs, and it's going to fall into the reactor in by hose. Everything is going to be connected by hose. Then they're going to be distributed in the containers that are connected, and the liquid will be dispensed. Well, most of the raw materials are liquid, and will be controlled by solenoid bulbs. And everything is going to fall again into the reactor, and it's finally going to mix and obtain our final product. And in my case, well, in my team case, we selected uh, disinfectant multipurpose cleaner because I mean it's easy to contain, easy to use, and it's super cheap. So we're not going to get any troubles with getting the raw material product. Then the objectives we have in this project are the automate to the manufacturing process of cleaning chemical products. We want to help enterprises to get a lot of bigger production, and also reducing the time that will take them to only produce a few chemical products. We also want to optimize the capacity and production times because, for example, if you take 1 hour to elaborate, for example, 1,000 kilos of one type of product, and it takes you like 2 hours, for example, in the reactor, you can take the same amount of time, but produce the double, and only one person will be needed. Then we want to allow a homogeneous mixture in the final product because every raw material must be mixed in perfect conditions so the clinic final product will work, because otherwise it wouldn't. And we also want to reduce the cost of enterprises by using this type of reactor because I mean it's going to be, I mean it's not super cheap, but it's going to be accessible, at least if you are in this industry. Well, here just an approximate cost of what are we wanted to use. We'll explain it further in the automation part, but here's just a quick review. We destinate most of all the load cells are the expensive because they have to be a good trademark, because otherwise it won't give us the exact kills we needed. We are going to get an Arduino One, Uno, or Mega. We already we don't know, but we will try to search for Arduino Mega because, in my personal opinion, it has more inputs and outputs, but it's something that we will discuss on the automatization part. I will need to talk with my team. Then we have the matrix keyboard, the solenoid bulbs, and a capacity sensor to detect the amount of fluid that is in the tank. And all of these will give us a total of 771 Mexican pesos. Then, well, here's the last part of the project, the Gantt diagram. We are only 3 people, which means that one of my people will have a little bit more of work. In my case, is me. I am the leader. I am on the document part and the design part. But we're going to help each other. We will start on September 26th, and we will only work on the weekends. That's because, well, in my case, I have to work. My other teammates are pretty busy with their work and personal life, so we decide to only put efforts on the weekends. We will start with the sketch, which is basically the easier part. And as you can see, every weekend we will advance on the writing on the document, because it's something that everybody can do at their own pace. But there are other tasks that might need a little bit more time. For example, like getting the materials, building that. Well, if we headache if we don't do it in time, we want to take our time to present a good project, and not only do it because we have to get good grades. Well, it's starting September 26th, 30, and And every weekend, we are going to present advances to our teacher. In this case, the automation part is the next part, then programming, and at the end document. But as I was saying, we are going to do tasks simultaneously because we don't want to get stressed or something like that. And well, I think the diagram speaks for its own. I think it's very visual. I just wanted to explain like a little bit, but I don't want to get much into it. So that's a quick review. And that will be all. Thank you for your attention, and see you next.